Good morning. Thanks for tuning into the video. Yeah, this is me just working hard, removing some rust off a 100-year-old wagon wheel. It turns out this wasn't always the case. Here was me about a week ago trying to get this same rust off. Grinders, whatnot. A couple days after that, you can see me using abrasive, harsh chemicals. I don't know how you metal workers do it. This sucks. I need to figure out a better solution. None of it was working, and so what I did is I got smart, and if you're tuning in this video, you're gonna get smart too, and I'm gonna show you the easiest, cheapest, most efficient way to remove rust off of any item. So I'm gonna take you back to the beginning of this setup to show you exactly what you need to make this a possibility for you, because no matter how small or how large the object, this will work. I'm also going to walk through some of the items as well as some of the pitfalls that you can hopefully avoid in making sure that you have a successful setup. And so at the end of the day, you can have a rust-free object yourself. Thank you so much for tuning in. Let's get to it. Removing rust by using electrolysis is actually a really simple, straightforward method that doesn't require a lot of items to get started. First item you're going to need is some wire. It can be copper or it can be regular middle wire. Something that's a big enough gauge that it's not going to corrode through, but also something that you can actually bend around your pieces of metal, both the piece that you are removing the rust from and whatever sacrificial anode that you're going to be attracting the rust to. When I say sacrificial anode, all I really mean is a piece of ferrous metal that you will basically use to sacrifice, because this is going to absorb all the rust. It's going to attract it all from that item. A simple piece of rebar is a really easy thing to find at any big box store, or you can use a piece of flat iron. Aluminum is not going to work. You cannot use galvanized steel. Again, I repeat, do not use galvanized steel because that creates a chemical reaction that is actually very dangerous. So stay away from that. Just a couple pieces simple rebar is going to be more than enough for you. You're also going to need water as well as an electrolyte for that water. In this case, we're going to use washing soda, which is just basically sodium carbonate. That's different than baking soda, which is sodium bicarbonate. So no matter what you read online or in any forums, do not use baking soda. Use washing soda. This is going to give you the electrolyte, the charge that you need in your water to actually make this work. This 55-ounce thing cost me about $5, so it's a super cheap, easy thing to get. And then the last item you're going to need is a battery charger. Any battery charger is going to do. Anything that is a trickle charger, has like a 2 amp setting on it, comes with some alligator clips. That's all you're going to need to make this magic work. And then just a container to put everything in. Depending on what type of item you're trying to get rust removed from, if it's like a small, simple wrench, you know, an item like this that you're going to fill with water, you could make that happen. Today, I'm going to show you how to go big. I am going to take this 100-year-old wagon wheel with many layers of rust and paint and you name it, it's on it. Now, the process is the same no matter how small or how big it is. So really, whatever item you're doing, you just need to find a container big enough to contain your item. In this case, for me, it's a wagon wheel. So what I did, bought myself a little $10 swimming pool, a little kiddie pool, and it's the perfect size for what I need. This is just to show you how I've set up my metal connections with my wires. You can do your setup however you want. I chose to connect it to 4 spokes of this wagon wheel, and I have one main wire that it's going to come off to the battery itself. You don't have to set it up like this. You can literally just have one wire go to one spoke and it's still going to do the job. Now the important part is what's going to happen next. These are my sacrificial pieces of rebar, and I'm just going to lay them down here in the bottom. They can be exposed coming out of the water, or they can actually be in the water itself. It does not matter. Here's the important part. When you are doing these type of connections, the only thing you need to make sure is think of this as your positive, and this wheel and everything connected to this wheel is your negative. And just like everything else, you don't ever want your positives and negatives to touch. So I'm going to take a minute and I am going to make sure that I can feed these wires underneath. They are not going to mess or touch like that while the electrolysis is happening. If they touch, well, if they touch, it's not going to work. So take some time, get your setup going before we even think about getting to the next stage. This step I'm doing right here it's not necessary, but I'm just doing it just to make sure that my wires stay above and that can rest assured that I know they won't be touching the other wires. So that's the only reason I'm doing this. This is just a little add-in. Next step, this is where your actual washing soda is going to come into play. We need to fill this up with water, and you really need about a tablespoon or so of washing soda per gallon. That doesn't have to be an exact science, so you know, I've got a pool here. I'm just gonna do this. That looks about right. It's not perfect, but like I say, the only thing we are doing is building a saturation, building a solution in the water to make sure that it can transfer that electrical charge. And it doesn't require a whole lot of washing soda to do this. Now all we have to do is just fill it up with water. Okay, we're ready to roll. Let's talk about what you actually tuned in for today. I need you to understand that today's current chargers, and one thing you're not going to find, is a lot of them will have a reverse polarity circuit inside of them. So old school chargers didn't have that. So you just hook it up, turn it on, and the bubbles start going. I'm just telling you, if you run into a problem where you plug it in and you're just like, there are no bubbles, why isn't it going? You may have a reverse polarity issue. It's essentially a safety thing, but it makes it really difficult when you're trying to do electrolysis. How do you get around that? Well, you get around that using this. You just get yourself a simple, you know, lead acid battery, whatever you may have lying around. This battery, what you're going to do is we're going to trick the charger into thinking that we're working with this battery, and that's going to trick that circuit. So I just want you to remember, this is the important part. Negative. The negative is the part that is hooked up to the thing we want to get the rust off of. So think negative, the rust is leaving. The positive is where we want the rust to go. In this case, we are talking about the rebar. Positive to where you want the rust to go, negative where you want the rust to leave. And so we are going to hook up our little alligator clips, one on the negative, one on the positive. Let's turn this bad boy on. People ask, is this dangerous? Well, I mean, not really. You're using a very, very low voltage. Odds of you having an issue are going to be really small. You do not have to keep this battery hooked up. You can literally take that wire, remove the battery at this point. And yes, you can see I touched the alligator clips. It's okay, I promise you. Respect electricity, but just understand in a process like this, it's going to be pretty straightforward and pretty easy, and with the low voltage going to it, there's not going to be an issue. And here's the good part. How do we know it works? Take a look right there. See those bubbles right there? We have electrolysis happening right now in each of these places, and you can see already the rust starting to rise to the top. So this shows me that we have a good connection. The electrolysis is working. Hey, I do want to note this really important thing. You see these bubbles? Those are hydrogen bubbles, so it's not just oxygen that's coming up. And I want to remind you that hydrogen is in fact flammable. So I would recommend you doing this outside or in a very well lit area, because they're small bubbles, it's going to take a lot, but technically it is flammable. So you do want to be safe with that, because that is hydrogen that you're seeing right now. A couple finishing thoughts that I did want to show you. Up close, you can see after the reaction has occurred, the results of what is going to happen to your rebar and all the rust that it's going to attract to it. I also want to note the copper lines that were used and submerged. See that little green right there? That's what's going to happen if you use copper wire. So if you don't want that, you can use any type of steel gauge wire. Should be just fine. But I just kind of want to show you some of the after effects after just one day, what the finished result is. And it is pretty incredible how much rust will come off of a piece. So pretty cool. And that's pretty much it. That's all there is to it. Depending on the size of piece that you're trying to get rust off of, this process can take anywhere between an hour and, in this case with a giant wagon wheel like this, I'm going on day 2. I actually rinsed out the whole thing and started fresh just to make sure that I was getting as much rust out of there as possible. A couple things to remember. Again, I will say this, I've said it before, galvanized steel is not where you want to go. That is dangerous. Do not use it. Any type of ferrous metal will do, but again, if you put a magnet on that piece of metal and the magnet doesn't stick to it, it's not going to work. Don't use that. Second, your car charger, whatever you're using, you may want to decide, you know, I'm going to pop it up to 15 amps or I'm going to put it on boost mode or something like that. Don't do it. It's not going to work faster. In fact, it's just not going to be as effective. You want something running at like 2 amps the whole time, because it is a steady, low voltage process that takes time to work. And so you don't want to rush it. Let it do its thing. 3, like I say, remember the battery trick. When I first did this, I was hooking it up and I wasn't getting any power whatsoever, and it was really, really frustrating because this is very straightforward. So just keep in mind, if you have a modern day battery charger that has a reverse polarity circuit in it, you may have to use the little battery trick and fool it into thinking that it's charging a battery. So take note, that may be very important for you. And then 4, get yourself a good cup of coffee, check on it every couple hours, and then come back and enjoy your hard-earned work. Either or, really appreciate you coming along in this one. Hopefully it was helpful for you. As you can see, it doesn't take a fancy setup to get something to work. Sometimes I tune into YouTube channels and I look at some of the videos that they've made and they have this super elaborate setup. You don't need a super elaborate setup. You just need something that's going to work. And so I hope this shows you it really doesn't take much to get the job done, and that's what's important. So either or, really appreciate you coming along on this one, and I can't wait to see you on the next one.